Welcome to a lesson with Dr. Powell. Let's look at the graph of r equals theta in polar coordinates. First, let's examine what the graph looks like for theta greater than 0. Okay, so for theta greater than 0, if we think of let's first think also about a coordinate system that we're comfortable with, Cartesian coordinates, r and theta. So this would be like r equals theta, like a y equals x type thing. We just have a slope of 1 going up like this. So what would this look like? Well, if we think about this, pi, 2 pi, and so forth, it looks like as we wrap around, as our angles change, so from 0, it gets, as we go around this way, it looks like our distance is getting bigger as we go. In fact, it's just going to spiral. Um, it's going to spiral over and just going to be this big spiral as we go. Now, so this is what it looks like starting from 0 as we go this way. Let's consider what it would look like when theta is less than 0. Okay, so let's take a look at this. What happens when theta is less than 0? All right, so we're down here, right? But it's easier to think about this when we draw it positively, when we're thinking about r values positive, so we need to kind of shift things around a little bit. So the interval from negative pi to 0, from here to here, if we shift it over pi, from 0 to pi, what's going to happen? We shift it over here, it's going to be the positive of this. So you take the absolute value of this, it reflects it up. So it's going to look something like this, okay, from 0 to pi. Now, what about this interval right here, from negative 2 pi to pi? Now, if we shift it over pi, it's going to be positive. If we shift it over another 2 pi, it's going to be negative again. Shifted another pi to right here, it's going to be positive. So the positive of this part going from here to here, reflected up, the positive version of that is going to look like something from here to here going up. Now, notice that this is at 2 pi, which is the same as 0, so these guys actually match up. So we'll actually have a line matching up. Let's see what this will look like. Kind of what we're doing is we're taking a piece over here of the graph, and then we're like translating it over here to see what it would look like positively if we change the angle. So meaning as we go from 0 to pi, so from 0 to pi, it looks like we actually start off right here, which would be at pi, okay, the distance of pi. So we'd start at pi, and then we would, as we head to, okay, so that's actually the r value because r is equal to theta. And as theta now goes from 0 to pi, so as we wrap around this way, it looks like we're heading down to 0. So it's gonna go spiral into 0. And then, okay, and then as we look from pi to 2 pi, so from here to here, it looks like, let's see, at 2 pi, let's do that. So at 2 pi, we're actually at, at pi again. But then as we go to negative pi going this way, let's see what happens. We're actually getting bigger. We're going to end up being up here, which is actually, so this is negative pi. This is actually negative 2 pi. So it's actually going to be way at 2 pi as we head back over. So we're going to be much bigger. So let's see, pi, and I can't draw it. It's going to be way over here. Let's just write 2 pi here. So that means as we go from here, we're at, so at okay, so this is 2 pi. So from here to here, so even though I've written pi here, this is the r value, okay? But this angle position right here is the 2 pi position. So at the 2 pi position, we're actually at this r value of pi according to this, and then we're going, then as we go back to here, let's see what happens. We're gonna wrap up. So when our position is at negative pi over here, we've actually wrapped all the way to 2 pi. So we've come up here. So we're kind of spiraling. So actually, when it's for the negative values, it's actually spiraling the other way like this. So if we put the two together, it's kind of like we're spiraling, we're spiraling kind of against, in opposite directions. So this one is spiraling this way and the other one's spiraling that way, kind of coinciding with each other. Notice how these two are just kind of like reflections this way of one another. So let's kind of think about that for a minute, maybe just in another way here. So let's just think about it. So this theta starts out negative. Okay, so if we're negative theta, then the r value is going to be negative over here. So well, quite literally, so as we start going up here for theta, we're actually going down here for negative theta. So, but we're actually going to be up here, right? So as we go around, we can expect, so as our theta is going this way and our r value is growing negatively, we're plops us up here. Once we get to this quadrant, we're going to be in here and still growing. And as we go around, we're going to grow like in that way. Whereas for positive theta, we just do what it says. We grow like that in that direction. So kind of interesting. You get two spirals, one the mirror image of the other one, just across here, by just considering theta being bigger than 0 versus less than 0 as we go. So this spiral kind of has two parts. So oftentimes for a spiral like this, we might specify that we only want one part, like theta greater than 0. And so then we would, like a parameterized curve even, and it would just come up and be like a big spiral going this way. Thanks for watching.